This is page 2 of the Algebra 1 pre-course test. This is material that you may or may not know, depending on how much exploration you do over the summer, how much you challenge yourself in math. So this is a function. This is called function notation. F of x equals negative 3x minus 2. And f of x just is the y value. It's your output. It's your dependent variable. So when we see f of x equals negative 3x minus 2, that's the same thing as saying y equals negative 3x minus 2. So this coordinate, let's do this. Can I separate you? Yes. So these are the same things. And your point here is x comma y. This is your input. This is your output. And this coordinate is x comma f of x. This is still your input. And this is still your output. It's not f times x, by the way. That's just f of x. So it's a single variable. They're stuck together. It's just a notation for a variable. This is a weird one, weird notation. And it says find f of x when x equals negative 8. So when x equals negative 8, so what we're finding is really f of negative 8. That really means f of negative 8. So what is f of negative 8? So you notice that we inserted a negative 8 for x. We're going to also substitute it for this x. Negative 8 minus 2. And so f of negative 8 equals 24 minus 2. F of negative 8 equals 22. And this is the proper notation. Now, the nice thing about function notation is we see what we inputted and we see what we output. So we actually have a coordinate here, input and our output. If we did it this way, y equals negative 3 times negative 8 minus 2, y equals 24 minus 2, y equals 22. We only know the output. I don't know, it's not clear with the solution what my input was. I'd have to go back into the equation. I'd have to remember. So that's the beauty of function notations, or one of the nice things about it. It can be hard, but I love functions. Functions are fun. So it says let f of t be the outside temperature in degrees Fahrenheit, t hours after 9 a.m. Explain the meaning of f of 1 is less than f of 14. So f of t be the outside temperature. So that's my temp. That's my output. And my input after t hours. So t is my input and t is time or hours. So after t hours, it's going to be a certain temperature. So this is after 1 hour. This temperature, so after 1 hour, this temperature is going to be less than the temperature after 14 hours. So this f of 1 is a temp, but we know that piece of information after 1 hour. So explain the meaning. So after 1 hour, the temperature outside will be less than the temperature after 14 hours. So in 14 hours, it's going to be a lot hotter. So as we progress throughout the day, I would assume that it just gets hotter. All right. So that's really important. That's a tough one. And after 1 hour, it would be 10 a.m., right? That's 10 a.m. It's going to be less than after 14 hours. So that's 11 p.m. So at 11 p.m., it's going to be hotter than when it's 10 a.m., which that's weird, right? It gets hot at night. That's an interesting place. Number 13, use the intercepts to find the graph of the equation. We know that when we look for the x-intercepts, all x-intercepts have a y value of 0, y equals 0, and all y-intercepts have a x value of 0. That's what brings it on to the y-axis. So we know that this is always true, that my x-intercept is always going to have an x value and 0 for y, and my y-intercepts are going to have a 0 for x value and some y value. So if I want to find the x-intercept, I'm going to plug in 0 for y into this equation. So if I plug in 0 for y and simplify, 3x plus 0 is 3x. Now I'm going to divide by 3, and x equals negative 5. So when y is 0, x is negative 5. So if I wrote that as a coordinate, that would be negative 5, 0. Let's do negative 5 on the x. 1, 2, 3, 4, 5, 0. So that point would be there, and that's why it's called an x-intercept, because it's right on the x-axis. And then my y-intercept, I'm going to plug in 0 for x into the equation that we have. So this time 0 goes in for x. That's 0 plus 5y equals negative 15. 5y equals negative 15. Divide by 5. And y equals negative 3. Now that's my y-intercept. So I plugged in 0 for x, and my output was negative 3. 0, negative 3 takes me there. And if I connect the dots and draw arrows on it, because I want to show that it goes on forever, we have that line. So we just graphed all of the solutions for this by finding 2 of the solutions. Let f of x equals x minus 2, graph g of x equaling f of 2x. Whew. All right, so g of x is going to equal f of 2 of x. So f of 2 of x we have to find. So we're going to input, this is my input, 2 of x in for x. So wherever I see x, I'm going to write 2x minus 2. And g of x equals this. So g of x, and we can't simplify, 2x minus 2. And now we got to graph it. Okay, this is in slope-intercept form. So I know this is my slope. I know that this is my y-intercept. So I'm going to plot my y-intercept first, and then I'm going to use my slope up to right 1, up to right 1. I'm going to connect the dots, and I'm going to do that. So that is the graph of g of x. Yeah, good. Number 15. Number 15, graphing absolute value. So compare the graph of f of x equals the absolute value of x. Find the domain and range. So graph the function, compare the graph. Okay, so this is the parent function. We call this the parent. It's the original. The parent function. So if we graph the parent function, plug in 0, you get 0. Plug in 1, you get 1. Plug in negative 1, absolute value of negative 1 is 1. Plug in 2, 2. Plug in negative 2, 2. And this is going to be the graph of the parent function. So it looks like this. This is what an absolute value graph looks like. It looks like a V. Then we draw little arrows. And so that is the parent function. We'll take this and we'll do again. And this time let's do a little graph. G of x equals the absolute value of x plus 5, and my output is going to be g of x. So if I plug in 0, I get the absolute value of 0 plus 5, which is 5. When I plug in 1, I get the absolute value of 1 plus 5, which is 6. When I plug in negative 1, that's going to be the absolute value of negative 1 is 1 plus 5 is 6 again. So let's plot those points. 0, 5. So 0 on the x, 5 on the y. 1, 2, 3, 4, 5. And then 1, 6, and 1, negative 6. Or negative 1, 6. So it looks like that. It's not a very good graph because it doesn't let me sort of graph those points. So that looks like this when we graph it. And I'm going to move that a little bit. Good. And we have, so notice it translated. The translation is up 5. That's the y-intercept. It shifted up 5 spots along the y-axis. So that is the graph of g of x. Good. All right, now we notice that the graph, this is the parent again. So we had those points. We can do those real quick because we're familiar or we remember them. So what does that look like? That looks like this. This is the parent function of the absolute value of x. Now, if we, again, let's do it in green. If we do inputting x, we have g of x equals negative 3/4 times the absolute value of x. My output is going to be g of x. So if I input 0, absolute value of 0, so this just equals negative 3/4 times the absolute value of 0, which is 0. If we plug in 1, now I probably don't want to plug in 1. If I plug in 1, I'm going to get a fraction. That's not going to be fun, but let's do it. We'll do it once. So 1 gives me negative 3/4 times the absolute value of 1, which is negative 3/4. Even if I did negative 1, we would still get negative 3/4, but I'm not going to use any more than these. I'm going to use 4 because that 4 is going to cancel. So we take the absolute value of 4, which is 4, which cancels with this denominator, and we get negative 3. And if I do negative 4, the absolute value negative 4 is still 4, which cancels, and I get negative 3. So here are my points. 0, 0. So right on top, same vertex right there. Then I do 1, negative 3/4. So 1 on x, negative 3/4 on y. And then if I do negative 1, I still got negative 3/4. And then I did 4. 1, 2, 3, 4. I got negative 3. 1, 2, 1, 2, 3. And then if I did negative 4, I still got negative 3. So let's connect those dots. And let's look at what, and this is called a dilation. So we dilated the parent and inverted it because of the negative. So this flips it over the x-axis, and then this is a dilation, so 3/4. So it spread it out. It made it wider than before. So oftentimes they ask you to describe what's happening. So it has a vertical shrink by a factor of 3/4 and a reflection over the x-axis. Yeah. Oh, and I think it asks for what find the domain and range. All right, so the domain and range. So the domain, what are my x values? Is all real numbers. And that just means any number can work for x because it's negative to negative infinity all the way to positive infinity. And then my range is an interesting one. What are my y values? Well, my y values go from 0 to negative infinity. So they can equal 0, and then they go to negative infinity, right? So that's one way of writing it, or we can say y is less than or equal to 0. That's probably a better way of writing it. This is the proper way. Let's do it this way. But you understand it's an and. That's an interesting one, but that still works. It's just weird that the negative infinity is over here. It might want to be over here. No, it's not less than. That's actually wrong. This is wrong. It should have been the other direction. Sorry. Right? Because, well, that's better. I don't know why I wrote it. People don't write that, though. This is just better. That's a better way because we go to negative infinity. Sorry about that if that's confusing. Write an equation in slope-intercept form of the line that passes through the 2 points. So if it's in slope-intercept form, it is y equals mx plus b. We have to find the slope. That's not how you spell slope. That's solop. Find the slope. And then we have to find the y-intercept. So you always have to find those two things from this equation. So finding slope is good. So number one is slope. And we're going to use the equation y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is the x value in the first point. This is the y value in the first point. This is the x value in the second point. And this is the y value in the second point, point 1, point 2. So it wants the y value in the second point, negative 5, minus the y value in the first point, which is negative 4, over the x value in the second point, negative 5, minus the x value in the first point, which is negative 5. So these two negatives, this becomes negative 5 plus 4. This becomes negative 5 plus 5. I made a mistake. I don't know what I was doing. Clearly, I was not paying attention. Y sub 2 minus y sub 1. X sub 2 minus x sub 1 is negative 8. Silly. Some of you caught that. So this is negative 5 plus 4. This is negative 5 plus 8, which gives me negative 1 over 3. And that is my slope. That can go into there. So my new equation now is y equals negative 1/3 x plus b. I still have to find b. I got to find this out. So I'm going to have to insert, in order to find this, I need to fill in for these two values. Do I have an x and a y? I do. In fact, I have two. Doesn't matter which one you use. I'm going to use the first point. So my y value is negative 4 equals negative 1/3. And then my x value is negative 8 plus b. Negative 4 equals, negative times a negative is positive. 8's in the numerator, 3 is in the denominator. And now let's isolate b by subtracting 8/3. And we have negative 4 and negative 8/3. Well, negative 4 minus 8/3. Let's make that thirds. So that's negative 12/3 minus 8/3. And that gives me negative 20/3. So negative 20/3 equals my b. And now I can finish my equation. This was step 1. I found my slope. Now I find my y-intercept. So negative 1/3 x minus 20/3 is my solution. That is the equation for the point. I must have made a mistake. What am I doing? Clearly, I made multiple mistakes. Why am I doing this? There's negative 1. That's good. No, that's not wrong. y's, x's. That's correct. 1/3. I think their answer key is incorrect. That was okay, right? 3, 1. I did that correct. -5 minus -4. -5 minus -8. That's correct. That becomes positive. It's -1. That's +3. -1/3. That's positive. Move it over. Yeah, that was correct. I didn't do anything wrong. That's good. Perfect. Love it. They're wrong. 18. Write an equation of the line that passes through 5.2 or 5,2 and is parallel to the line. So things we need to know. Parallel lines have the same slopes. And different y-intercepts. So that's number 1. Perpendicular lines have opposite reciprocal slopes. Okay, so they tend to ask this question whether it's parallel or perpendicular. So we know that the slope of this line equals -1. So since it's parallel, my line parallel to it containing this, so I know that we start with y equals mx plus b. I just found the slope. And again, I'm going to plug these values in. My y value is 2. My x value is 5. 2 equals -5 plus b. Add 5. 7 equals b. And so this equation is y equals -x plus 7. We wouldn't write -1, we write -x, or we wouldn't write -1x, we write -x. So that is the proper way to do that. And that's it. You're done. That was page 2 already. Good. Keep working. Definitely. You probably know some of the stuff, and then you were sort of maybe a little quizzical about some of the other stuff. Good luck.